Okay, let's have series of examples on machines. Problem 84. A couple M of magnitude 1.5 kilonewton meter is applied to the crank of the engine system shown. For each of the two positions shown, determine the force P required to hold the system in equilibrium. So take note that B will move, A is free to rotate but cannot move horizontally and vertically. So that this couple is applied on AB, so this piston will adjust itself. So that's why you have this force P here. So the force in link BC is denoted by PBC and it is expected to be in compression. So this is the second situation. So again, A is fixed horizontally and vertically, but it can rotate, while B is free to move. So we call the force in BC as PBC as shown. So let's consider AB, and these are the expected component reactions at A. So considering AB, summation moment about A equals 0 to solve for this PBC here, but the angle is arctan of the angle that PBC makes with the horizontal is arctan of 50 over 175, and that is 15.945 degrees. So considering AB, summation moment about A equals 0, counterclockwise positive. So PBC, the horizontal component, is counterclockwise. The vertical component upward is also counterclockwise. So both are positive, then equate to clockwise moment, which is 1.5 kilonewton meter. So PBC cosine of 15.945 degrees times 50 plus PBC sine of 15.945 degrees times 75 mm equals m, which is 1.5 kilonewton meter. So we anticipate that because the units of moment is kilonewton meter, so we express the distance 50 mm and 75 mm in meter, so that PBC is in kilonewton. So equals 1.5. Solving for PBC, PBC is 21.84 kilonewton. So 0.05 meter is 50 mm and 0.075 is 75 mm. Having found PBC, we consider the piston and BC. Summation forces horizontal equals 0. Summation forces X equals 0. So PBC 21.84 cosine of 15.945 equals P. So from here, P can now be computed. It is equal to 21.01 kilonewtons, and the direction is correct. For part B, so again, we call the force in BC as PBC. Then component reactions at A, this time rightward because PBC is leftward. So AY is downward this time because PBC is upward. AY supposedly at A is also downward, but it doesn't matter. We only need PBC. So the angle that PBC makes with the horizontal is arctan of 50 over 175, so it's the same, 15.945 degrees. So the horizontal component is counterclockwise about A, while the vertical component is clockwise about A. So therefore, summation moment considering AB about A equals 0, counterclockwise positive. So the horizontal component is counterclockwise, the vertical is clockwise. So horizontal component PBC cosine of 15.945 times 0.075 minus times 0.05 minus PBC sine of 15.945 times 0.075, then equals clockwise moment 1.5. So solving for PBC, PBC is 54.6 kilonewton. So considering BC and this piston here, summation forces X equals 0. So PBC 54.6 cosine of 15.945 equals P. So P is also leftward. P is equal to 52.5 kilonewtons. So that's it for this simple machine. So for the second example on machine, problem 85, two hydraulic cylinders control the position of the robotic arm ABC. Knowing that in the position shown, the cylinders are parallel, so we have cylinders AE and DG as parallel, or GD. Determine the force exerted by each cylinder when P is 160 newtons and Q is 80 newtons. So let's substitute the value of P, 160 newtons, Q 80 newtons. So since we expect this is in tension, so when the effect of 160 newtons causes it to rise, so this should be in tension, we will call the force in AE as PAE, and it is tension or away from A. Then the slope of this is 3 horizontal, 4 vertical, so 5 hypotenuse. Likewise, at B, we have these component reactions, Bx and By. And let's consider first ABC, the upper part. So consider ABC. Summation moment about B equals 0 to solve for PAE. So the slope of PAE is 3 horizontal, 4 vertical, so 5 hypotenuse. There are two components of PAE, horizontal, which passes through B, so it has no moment, and the vertical, which is PAE times 4 over 5, so it is counterclockwise. So summation moment about B equals 0, counterclockwise positive. So vertical component of PAE is PAE 4 over 5, moment arm 150, is equal to 160 times 600. Of course, the 80 Newton force passes through B. So PAE times 4 over 5 times 150 equals 160 times 600. From there, we can solve PAE, and it is positive, so it is tension. 800 newtons tension. Now we will not touch that. These are internal pins. So we transmit the 800 Newton force at E this time. So let's remove these forces. And let's consider the free body diagram shown. So we assume that PGD is in compression because of this short extension. So call that PGD. So remember, the slope of PGD is the same as this cylinder here. So if we sum up moments about F equals 0, considering the entire system, then the PGD has two components, vertical, which produces counterclockwise movement about F. The horizontal component passes through F, so it is only the vertical component that has moment about F. So summation moment about F equals 0 and counterclockwise positive. So we have PGD times 4 over 5, that's the vertical component, times 200, then plus the vertical component of 800 produces counterclockwise movement also. The horizontal passes through F, so it's only the vertical component. So plus 800 times, so PGD times 4 over 5 times 200 plus 800 times 4 over 5 times 150, then plus 80, this is also counterclockwise, times 400, then equals clockwise movement 160 times the total distance to E is 600 plus 150 plus 300, that's 1050, then minus 150, so it's just like removing this, so 900. The moment arm of 160 from F is 900. So equals 160 times 900. So only PGD is the unknown here. If it is positive, so it is correct that it is in compression. So PGD is positive, so 1000 newtons compression. So that's the answer to this problem. So for the third machine problem, example 86 or problem 86. The bucket of the front end loader shown carries a 3,200 pound load. The motion of the bucket is controlled by two identical mechanisms. So one of which is shown. So only this part is shown. The other is the duplicate. So therefore, the mechanism supports only one half of 3,200. This is the total weight. So half of this is supported by one mechanism. Determine the force exerted by cylinder CD, this cylinder here, and the cylinder FH, this cylinder here. So first, to solve for force in CD, we must consider first the bucket half, then the force in AB. Let's solve that first. We cannot determine directly the force in cylinder CD because there are two component reactions at E. So let's solve for the force in AB or link AB, which is expected in tension. So let's draw the free body diagram. So call that PAB. Then PAB is, PCD is assumed to be in compression. And there are two component reactions at D, dy and dx. So considering these forces, summation moment about D, we can solve PAB. Now take note the dimensions are in inches and take note that this is only half of 3,200 pounds. So consider the bucket and the forces shown in the figure. Summation moment about D equals 0. So clockwise positive. So PAB times 16 then equals 3,200 over 2 times 15. So PAB times 16 equals 3,200 pounds over 2 times 15. So therefore, PAB is 1,500 pounds. So it is correct. It is tension. Next is, because these are internal, we transmit the value of PAB. So let's consider BCE this time. And let's remove these forces and reactions. So it's just like we consider this body BCD. And remember that PAB is 1,500 tension. And this time the force in CD is assumed to be in compression, which is compression here also. So therefore we have two component reactions at E because this is a pin, EY and EX. So the angle that PCD makes with the horizontal, so let's extend it, is arctan of vertical distance is 16 minus 8, so it is 8, then the horizontal distance is 20, arctan of 8 over 20, where 8 is 16 inches minus 8 inches, and 20 of course is that horizontal distance between C and D. And that is arctan of 8 over 20 is 21.801 degrees. So PCD has two components, horizontal and vertical. Horizontal is rightward, vertical is upward. So the horizontal component produces clockwise moment about E, while the vertical component produces counterclockwise about E. So let's consider clockwise as positive. Summation moment about E equals 0, clockwise positive. So the horizontal component is positive. PCD cosine of 21.801 times 15 degrees, 15 inches. Then the vertical component is counterclockwise, so minus PCD sine of 21.821. The horizontal distance between C and E is 20 minus 15, so it is 5. So minus PCD sine of 21.821 times 5. Then equals counterclockwise movement 3,200 over 2 times we sum up moment about E, So times 30, 15 plus 15. So times 30. Plus 1,000 or equals 1,500. Sorry, we consider only BCD, so equals 1,500 times 23, where 23 is 8 plus 15. So remember, we only consider this body, so we do not consider 3,200 because we transmit the forces in BCE. So it's not included, so only these forces here. So therefore, we can now solve PCD. PCD is equal to 2,858 pounds, and it is correct positive, so compression as shown in the figure. And finally, to solve for force in FH, we remove these internal forces, and let's consider the free body diagram shown. So that's PFH. The angle that PFH makes with horizontal is arctan of uh, the vertical is 6 plus 24, 30. Then horizontal is also 24 plus 6, so 30. So that's why it's 45 degrees. So this is the free body diagram. So we do not touch the pins. So we only consider these forces. And of course, we have reactions at G also. So the 3,200 pound divided by 2 is considered. So it will have effect here. So summation of moment about G equals 0. Then this time clockwise positive. Consider the FBD shown and these forces. So summation of moment about G equals 0, clockwise as positive. So vertical component is clockwise. Vertical component is clockwise. Horizontal component leftward is counterclockwise. So it's minus, then equals counterclockwise moment 3,200 over 2 times moment arm up to G, which is equal to 24 plus 1640 plus 2060 plus 1575. So again, vertical component is clockwise, PFH times sine of 45 times 24. Then the horizontal component is clockwise, so minus PFH cosine of 45 times 6 minus or equals 3,200 over 2 times 75, where 75 is 24 plus 16 plus 20 plus 15, so 75. So solving for PFH, we assume it is in compression here. So I think this is positive, so therefore it is compression. So PFH is 9,428 pounds compression, as shown in the figure. So that's it. That's also the answer to this problem. So lastly, for this last example, problem 4, or problem 87, on machines, determine the magnitude of the gripping forces produced when the two 300 Newton forces are applied as shown. So when you apply this 300 Newton force, it will have gripping force develop here at this gripping portion of the handle of this mechanism. So we cannot determine it directly, so we only consider this portion first. So the effect of the 300 force will cause AC to be in compression, and because this is attached to this smooth pin here, so there are two component reactions at T. So we will call the force compressive force in AC as PAC. Let's consider first the lower part, and the component reactions at D are namely dy and dx. Then PAC makes an angle of arctan of vertical 30 over horizontal uh, 120 minus 30, sorry, 96 AC. The horizontal distance of AC is 96 minus 12. So 84. So arctan of 30 over 84, inverse tangent of 30 divided by 84 is 19.654 degrees. So it is 19.654 degrees. That's the angle with the horizontal. So if we sum up moment about D, we have two components, vertical and horizontal. The vertical component produces counterclockwise moment about D. The horizontal component produces clockwise moment about D. So let's consider counterclockwise positive. So consider the lower portion of the handle CD and forces. Summation of moment about D equals 0, counterclockwise positive. So the vertical component is counterclockwise, and that is PAC sine of 19.654. Moment arm is 30. So PAC sine of 19.654 degrees times 30 mm. Then the horizontal component is clockwise, so minus PAC cosine of 19.654 times 6 mm. Then this is also clockwise, so equals 300 times 126. 96 plus 30 is 126. So solving for PEC, if it is positive, it is correct compression. So PEC is 8514 newtons compression. Then we remove these forces. Let's analyze the upper handle AB together with the gripping force. And let's transmit PAC 8514 newtons. So at B, we have two component reactions also, namely Vx and Vy. Then we have the gripping force. Let's call the gripping force as F1. So the gripping force produces moment about B, which is counterclockwise. So let's sum up moment about B, counterclockwise positive. So 8514 has two components, vertical and horizontal, but the horizontal component passes through B, so it produces no moment. And the vertical component is clockwise. So F times 36, that's counterclockwise, plus 300 times 12 plus 120, 132, then equals vertical component of 8514, which is 8514 sine of 19.654. The moment arm is 120. So 8514 sine of 19.654 times 120. So solving for F, which is the only remaining unknown, so F is 8445 newtons. So that's the gripping force, and I hope that you know how to solve problems on machines by constant practice, and you study the solutions to these four problems here, and you extend by solving more problems on machines, you will be able to master problems on machines.